Hi students, we're going to look at trigonometric functions, starting our unit on this, and I want to reacquaint you with something you've heard before, and you may have heard it as SOHCAHTOA, and these are the ratios. The S being for sine, cosine, and tangent, and their ratios, and I want you to copy this chart as well as this one, the reciprocal of those functions being the cosecant, the secant, and the cotangent. And they're all going to come into play in this unit, so make sure you take these notes. But let's work on how do you solve for a right triangle. Let me do an example for you. Okay, so here's how we solve a right triangle, which simply means find those leg lengths. So I'm given this angle and this hypotenuse side. So step one says make sure that your calculator is in degree mode. So you go to mode and make sure it's not in radians, but it is in degree. Step two, using the angle that was given as a reference, so this 40 is my reference angle here, determine the position of the given side. Okay, as it relates relative to this position, I'm given the hypotenuse. That, okay, it says here, is that the opposite, adjacent, or hypotenuse? That's your first indicator. So I know that I have 40 degrees and I have a hypotenuse. And now, step three is mark the side you're trying to solve with a variable. So I think I'll solve for this side. And now determine its position relative to the angle. Well, this is positioned opposite to the angle. So you're always comparing it to the angle, and it's opposite. Now that is going to be your second indicator. Use those two indicators to identify the function you want. For instance, if it's OH, that's sine. That's why they say so. If it's AH, that's why they use cosine for ca. And if it's OA, that's tangent. SOHCAHTOA. So that gives you the function you're going to use. So since I have opposite hypotenuse, that has to be sine. So the next step is to set it up as an equation, an algebraic equation, and solve. So you always write the function, the angle, and if it's SOHCAHTOA, the middle one will be the numerator, and the opposite is my x, and the hypotenuse is my 50. So I'm simply replacing the letters with the values, and I'm going to solve. Well, if I need to solve for 50, for x, I simply multiply both sides by 50. So I'll take 50 times sine 40. I will not do sine 40 and then, can you hear my dogs snoring? I'm not going to do sine 40 and then round it. I'm going to actually punch in my calculator 50 times sine 40. I'll round once I've done that. So at this point, I've multiplied that and I got 32.14 is x. So now I know this side is 32.14. Now to find this side, I can either do Pythagorean theorem and do 50 squared minus 32.14 squared, find this and find the square root, or I can just now solve it using, let's say, tangent. So I'm going to call this y. I'm going to go through this again. Let me show you how I would set it up. I'm just going to say tangent of 40, because that's TOA, right? TOA. Tangent equals the opposite of 32.14 over the y. And now I'm going to solve for this y. So this time I'm not going to multiply, but, well, I guess I could multiply both sides by y and then divide, but I know that I'm really just going to take this number divided by tangent to solve for y. So I crunch that, and I get 38.3 is equal to y. So I have completed 38.3 solving my triangle. Now, if they ask you something like this, look at this question here. It says, find the value for the 6 trigonometric ratios of theta. So this is my theta, and I am going, I need another color. Let me use blue. And so in all other words, all they want me to do is, what is the sine of theta? The sine, now remember, let me write it again. SOHCAHTOA TOA. The sine is the opposite over the hypotenuse. So it's 30 over 34, which actually is 15 over 17, right? You need to simplify them each time. And now the cosine is, of course, cosine is adjacent over hypotenuse, so I have 16 over 34, which is actually 8/17, isn't it? If I simplify. And this is how I complete this chart. So if you will pause and try to complete the chart. And here's my chart. Now I want to make one point here, and that is this. Well, I actually want to make two. This hypotenuse, even though it's adjacent to that theta, can never be called adjacent. It is a hypotenuse. That is its identity. It never can be considered the opposite, nor can it be considered the adjacent. Its name is h. It's the hypotenuse. So don't let that throw you just because it's attached or adjacent. Don't be fooled by that. And one more thing, if I wanted the angle measure of this, I would simply put second sine in my calculator, second sine, and then I'd put 15 divided by 17, and it'll look like this in your calculator. And if you do 15 divided by 17, it will give you that angle measure. So that's how you can find the angle measure given the sides given the angle measure. You guys take care.